Amusement Park Data, Part 1, Measuring Distances. First, we'll start with how to measure horizontal distances when we're at the amusement park. We will use our pace, and your pace is the average distance that you move per step. So you need to measure and count how many steps it takes you to move some known distance. So it took me 16 steps to move a distance of 12 meters. So that means that my pace is 12 meters. The distance divided by the number of steps gives me 0.75 meters per step. So that's my pace, and you should know your own individual pace so that you can use it to calculate distances. Here's an example. At the amusement park, I counted that it took 49 steps to walk from one end of a ride to the other end. How long was the ride in meters? Well, the distance is going to equal the number of steps. So 49 steps times my pace, which was 0.75 meters per step, which gives me 37 meters. Okay, so we've converted from steps to a distance in meters. Part B is measuring vertical distances, and we'll have two methods for doing this. The first method is to use multiples of a known height. So we can have somebody stand in front of the roller coaster or the big slide or the Ferris wheel, and if we know their height and we estimate how many of those people would need to be stacked up to reach the top point, we can calculate the height. So here the estimation is that it would take about 3.6 of these people. So 3.6 times the person's height would give us the height of the building. So that is our first method for measuring a vertical distance. And our second method is going to be using an Astrolabe. And this is what it looks like. It has a straw along the top that you can look through with your eye. And what you do is you sight at the highest point on the building or the roller coaster or whatever it is that you want to know the height of. So you're looking at that point through the straw. And there's some BBs inside this plastic tube that are free to roll. And they are going to, because of the force of gravity, be directly below this point here. And from that angle, the zero angle is here. So from this angle, we're able to actually measure and figure out the height. So here's the procedure. Stand some known distance from the tall object whose height you want to measure. Sight through the straw at the top of the object, and then record the angle of the center BB. There are 3 BBs in there so that the friction will sort of slow them down and reduce the oscillating back and forth. So we'll just focus on the center BB. Here's a diagram of the setup. So this here is the tall building or the roller coaster that we want to know the height of. So capital H is what we're looking for. It's the height from the ground to the maximum point. This is the person. HO, H naught, is the height of the person's eyes above the ground. And then you'll see there's a triangle here, and this part of the triangle we will call Y. And so the height of the roller coaster is going to be Y plus this part, which was H naught. Now here's our person looking through the Astrolabe, and you can see the BB is right here, and there's some angle, theta, that we could read on the Astrolabe. And in the next slide, I'm going to explain and convince you, hopefully, that this angle that's shown by the Astrolabe is this same angle in this large triangle. And before I do that, the last important thing here is that this horizontal distance from the tall object to the person is little d. Now, this is the triangle I wanted to point out, and I'm going to show you that this angle theta is the same as the angle inside the Astrolabe. So here is our large triangle again. Here's the angle theta inside the Astrolabe. Now if you look at this angle here, this whole thing, from the zero line of the Astrolabe to this hypotenuse of the triangle, that is a 90-degree angle. So if that's a 90-degree angle, and this part of it is theta, then the other part of it must be 90 minus theta. Now consider this triangle that consists of a right angle down here, the green angle, and the purple angle. Those angles all have to add to 180. So if this is 90 and this is 90 minus theta, this one has to be theta. Now that we have determined that this angle is theta, we are ready to figure out what y is, so this height here, in terms of other things that we know. Because we know that this side of the triangle is D, and that's something we can measure by pacing at the park. And we know the angle theta. We can get that reading from the Astrolabe. So using our triangle, we can write the expression that the tangent of theta, so here's my theta. Remember that tangent, using SOHCAHTOA, tangent is opposite over adjacent. So the side that's opposite the theta is y. The side that is adjacent the theta is d. So tangent theta is y over d. And solving that for y, we get y equals d tangent theta. And now we're going to substitute this expression for y into our equation for the height of the object. So the height of the object is the height of the person's eye plus y, which is d tangent theta. Here's an example. Using an Astrolabe to measure the height of my neighbor's house. So the height of my eye is 1.70 meters from the ground. The horizontal distance when I walked from their house to the place where I was standing with the Astrolabe was 25 steps, and the angle reading on the Astrolabe was 20 degrees. And here's the equation. The first thing I need to do is convert my steps to meters using my pace. The next step is to substitute my values and calculate. So here's the height of my eye, h0. Here's the horizontal distance, d. And here's the tangent of the angle reading on the Astrolabe. And calculating that out, I get that the height of the neighbor's house is 8.5 meters. So summary, measuring distances. To measure horizontal distances, we're going to use pacing, so count the steps needed to cover the distance and then use your pace to convert that number of steps to meters. And when measuring vertical distances, we can use multiples of a known height by estimating the height of the object in multiples of some known person's height, or we can use the Astrolabe. And to use an Astrolabe, you need to measure the height of your eye above the ground, the horizontal distance, and you need the Astrolabe reading for theta, and then you can use the equation we derived to calculate the height.